Here we're going to simplify each of these rational expressions, and these involve more than one variable. So we're going to take a look at what that entails, and it's really the same idea. We're looking to factor things and cancel factors of one, but sometimes it can look a little bit different if you have more than one variable in the mix. In this first example, we have x squared y minus xy squared in the numerator, all divided by x squared minus y squared. All right, so the first thing I'm going to look for is what can I factor out? So in the numerator, I notice that both of the terms have an x, right? The first term has an x squared and the second term has an x, so I can factor an x out. And each of those terms also has a y, right? And the second one has a y squared. So, but minimally, the greatest common factor there is xy, right? So that would leave, if I factor out xy from x squared y, that leaves x, right? And if I factor xy out from xy squared, that leaves y, right? If I take out an x and a y, that's what's left. Okay, so I have xy times the quantity x minus y in the numerator. In the denominator, with x squared minus y squared, I notice that there isn't anything common to those terms that I can pull out. But what I do notice is that it's the difference of squares, right? X squared minus y squared. So I can factor that as x plus y times x minus y times x minus y. Okay? And I can cancel out x minus y, leaving me with xy divided by x plus y. All right, now be careful here. You know, we're thinking about domain restrictions. I didn't list that in the directions here, but what would make it's a little bit different with the two different variables, because what you're really thinking about here is what makes x minus y 0, right? Because that's the factor that we canceled out there that was in the denominator that is no longer in the denominator. So if I add y to both sides, then that means that x is equal to y, right? It makes good sense. I mean, if x and y are the same value and we're finding their difference, it's going to come to 0, right? So I would say up here as a domain restriction, x can't be y, right? If that's the case, then we're going to have some issues. All right. So now let's look at this other example of 4r minus 8t, all divided by r squared minus 4rt plus 4t squared. All right. This is a little bit different. So in the numerator, the only thing I can do is factor out a 4, right? So I've got 4 times the quantity r minus 2t. Okay, and in the denominator, I notice the first term and the last term are both perfect squares, right? R squared is a perfect square and 4t squared is a perfect square. And so often when that happens, it's what's called a perfect square trinomial, and the middle term has to work out that way for it to be the case. But let's try it. Anytime I notice stuff like that, that's the first thing I do. And we're subtracting the middle term, so I'm going to have r minus 2t times r minus 2t. Okay, so let me look at that for a minute down here. So with the different variables, sometimes it's helpful to just take it onto a different piece of paper. Take a piece of scratch paper to it here. So if we've got r times r, right, I'm just foiling this out, that's r squared. The outer term is going to be r times negative 2t, which is negative 2rt, right? And the inner term is going to be negative 2t times r, which is minus 2rt. And the last term is going to be negative 2t times negative 2t, which is plus 4t squared. Okay, so what is that middle term? R squared minus 4rt plus 4t squared. Yes, okay, so I just wanted to make sure that my factoring was correct on that. Okay, so when you notice things like that, like in the first example we did, if you notice the difference of squares, if you notice that your first and last term is a perfect square, see if it's a perfect square trinomial. So that means that, hey, it's the same binomial squared, essentially. Okay, so going back up here, we can cancel out a factor of r minus 2t, right? Which leaves us with 4 divided by r minus 2t. Now, in terms of a domain restriction, because the r minus 2t still is listed in the denominator, we don't have any hidden domain restrictions, right? What we canceled out is no different than what's already there. So in terms of what makes the denominator 0. So we don't have to list any domain restriction there. Okay, very good. All of this factoring, it's the same kind of stuff as what we were doing when we only had one variable, but it can look a little bit different. And I encourage you, if you're factoring and things, go ahead and FOIL things out like I did here. I didn't do it with the difference of squares in the first example, but that second example with the perfect square trinomial, sometimes it helps you just to see it. Okay.